Okay, so this is going to be Unit 3 of Mathematics that we are going to be doing today. So I am going to teach you based on the slides that we're going to start playing right now, and hopefully you will understand. If you have any questions, please do ensure that you text me, and I will explain everything to you in detail. So let's just start from the very beginning. Welcome to the second unit. It's supposed to be the third unit actually, so there's just a little mistake on that. So please enjoy today's lesson. Well, today we're going to be focusing on factorization. Well, let's get started. Before we get down to business, we have to do some revisions based on the factorization, based on something that you have learned from currently doing grade 10. So let's just work with the laws. Whenever you have x, it's just basically x to the power of 1. For example, if we have 6, it means that it's 6 to the power of 1. So 6 to the power of 1 and 6 is practically the same thing. And whenever you have x to the exponent of 0, the answer will always be 1, meaning that anything that is powered by 0 is going to be equals to 1. For example, when we look at 7, 7 to the power of 0 is equals to 1. If you put that in the calculator, put any value you wish, maybe even put a million there, and then say to the power of 0, the answer will always be 1. And then whenever you have x to the exponent of negative 1, it means that it's going to be 1 over x. The answer is 1 over x. Let's just put that practically. Whenever you have, for example, 4 to the exponent of negative 1, the answer that you get is 1 over 4. Meaning that even if you have 1 over 2, which is a half, you can write it as 2 to the exponent of negative 1. And then, this is just a quick revision on some laws of exponents, but we'll get to that in detail as well. Whenever you have x to the power of m multiplied by x to the power of m, you can write it as, or is the same thing as, or it is equals to x to the power of m plus n. Let's just put that practically. Whenever you have x to the power of 2 multiplied by x to the power of 3, this will be equals to x to the power of 2 plus 3 equals to x to the power of 5. Meaning, whenever you have the same bases, whenever you multiply the same bases, you add the exponents. And then we have x to the power of m over x to the power of n. Whenever you divide figures or expressions or whatever we want to call it, whenever you divide something that have the same base, whenever you divide two things that have got the same base but different exponent, what you do is you subtract the exponent. Let's just put that practically. Imagine having x to the power of 6 divided by x to the power of 2. The answer will be, or how to solve that will be, x to the power of 6 minus 2, which will be x to the power of 4. Imagine now having close bracket or inside brackets multiplied by n, which is just an exponent. This is a little bit different from this one because this one has got a base, this one does not. So in other words, you are multiplying 1 to the power of n with x to the power of m. So what you do from there, you just basically multiply the exponents. Because then now it's going to be x to the power of mn. Let's just put that practically. Imagine now having x to the power of 2 inside a bracket to the exponent of 3. What you do is you're going to say x to the power of 2 times 3, which is going to be x to the power of 6. Imagine then now having xy to the power of n equals to, or whenever you have a bracket that has got two different bases and then outside it is multiplied by an exponent. What you do is that exponent belongs to both of them. Think of this as more like x being a mother and y being a father and being a child. It means that the child belongs to both the mother and the father. So that's why the answer will be x to the power of n, y to the power of n. Let's just put that practically as well. Imagine having x, y to the power of negative 3. The answer will be x to the power of 3, y to the power of 3. And then now, let's move on to something else. To continue, imagine having the same thing, but then now dealing with fractions. Imagine having a fraction inside a bracket whereby it is multiplied by an exponent. Imagine having x to the power x divided by y to the power of n. This is still going to be the same thing as the one above. X being a mother and y also being a father. For example, n being a child. This means that this n will belong to the mother, this child will also belong to the father. So meaning the answer will be x to the power of n divided by y to the power of n. To put that as an example, we are going to say x divided by y, for example, squared. That squared or that power 2 will belong to both x and y. So you're going to have an answer of x to the power of 2 divided by y to the power of 2. Remember, when we're working with negative exponents, that is automatically a fraction. When you have x to the power of negative n, remember, when you're working with fraction, just like what we did here, x to the power of negative 1, we said the answer here will be 1 over x. So whenever you have x to the power of negative n is the same thing as x to the power of negative 1n. Therefore, you're going to have it as 1 over xn. Practically, imagine now having x to the power of negative 3. The answer here will be 1 over x to the power of 3. It is just the same thing as having x, let's just say 2 to the power of negative, okay, let's just say 3 to the power of negative 2, for example. The answer there will be 1 over 3 to the power of 2, which will be 1 over 9. And then we have the law about the fractional exponents. Now when we're working with a little bit much more complex situations, imagine now having x to the power of a fraction or a base to the power of a fraction. Imagine the exponent now being a fraction, for example x to the power of mn. This will be equals to the nth root of xm. The nth root of xm. And how you can simplify that is, you're going to say the nth root x outside the bracket exponent m. To put that in a logical way or in a way that you will understand, imagine now having x to the power of 2 over 3. You're going to say the cube root of x to the power of 2 or x squared. You can actually take this square and put it outside the bracket, whereby now the answer will be the cube root of x squared. So this is just basically factorization, whereby whenever if you're given this as an answer, you can automatically move back to this point. I hope you understand. Moving on, we are going to look at the ways to factorize. Think about the ways that you already know on how to factorize. We're going to work on those very same ways. The first way we're going to learn about is going to be the common factors. A way to factorize, one of the ways is called a common factor. We find and take out a common factor that can divide into each term in the expression. For example, in the expression 6h to the power of 3 plus 18h squared, we can then say 6h squared can divide into each other or in each term, so it becomes a common factor. Think about it. How to tell if you have a common factor? If we have this 6h to the power of 3 plus 18h to the power of 2 as our expression, think about the highest number between 6 and 18 which can go to both of them, or which can divide into both of them without leaving any remainder. Think of 6 firstly, think of the lowest one and see if it goes into both. 6 can go into itself, and then 6 can go into 18 to prove 6 plus 6 is 12. 12 plus 6 is 18, so it goes in 3 times. And then look at the variables themselves, or the bases, and see if they are the same. If they are the same, then you can also include that as one of your common factors. For in this case, we are working with h and h. So look at the highest exponent. The highest exponent will be 2 and 3. So therefore, 6h squared can go into both of these. This is how we find out. For example, this is exactly what I was saying, but then I'm just going to take it in a way that you will understand. First off, if you have 6h cubed divided by 6h squared, the answer you will get will be h. How do I know? 6 and 6 will divide into 1. When you have h3 divided by h2, which we just learned about it in the laws of exponents. When we divide two things of the same base with different exponents, we subtract the exponents. So it's going to be h to the power of 3 minus 2, whereby you're going to get it as h, which is the answer that we have here. Think of this. If we say 6h squared is a common factor, then it should divide into both of them, right? So 18h cubed, if you divide it by 6h to the power of 3, what answer do you get? The answer that you get from this will be 3. How do you know? You know this because 6 can go into 18 3 times. When you divide 18 with 6, you will get 3. H cubed and h cubed will divide each other. What is the aim of this? The aim of doing this step is just to show you that these two terms can divide each other and not leave a remainder. In terms of remainder, we're talking about decimals. So I'll repeat this. The reason why we do this is to prove the fact that these two terms can divide each other and not leave a remainder. Therefore, 6h to the power of 3 plus 18h to the power of 2 is equals to, you take out the common factor which you have already found, 6h to the power of 2, open bracket. How to get this? What is it that I can multiply with 6h squared to get 6h cubed? Simple. H. If you multiply this, you're going to get 6h to the power of 2, or to the exponent of 2 plus the 1 which is here. And you're going to get 6h to the power of 3 plus 6h to the power of 2 multiply 3, or what is the number that I can multiply 6h squared with to get 18h to the power of 2? 3. If I multiply this with this, I will get 18h to the power of 2. If you don't believe me, please do prove that. The next thing that we're going to look at are on the ways of how to factorize. This is called the difference between two squares. The difference between two squares. A difference of two squares occurs when we have two perfect squares separated by a minus sign. An expression in the form of a squared minus b squared has two factors. What we mean by that is, if we have this, then we can write it as this. If we have a squared minus b squared, we can write it as open bracket a minus b, close bracket, open bracket a plus b. Let's just put this in a logical way. For example, x minus 5 squared. You can write this as x minus 5, open bracket x minus 5. And then you will get it as, there's a mistake here. Please do rectify that in your writing, when you are writing or when you're copying down. It's still going to be the same procedure, but the answers may be different because of the mistake which was done here. Here it's supposed to be a plus 5. So, as you already know from your grade 8 and grade 9, x will multiply x will multiply negative 5 will multiply x, and negative 5 will multiply negative 5, in which the answer you will get will be x squared minus 5x minus 5x plus 25. Then from there you are going to get x squared minus 10x plus 25. The next thing that we're going to look at is called perfect squares. In Unit 2, or in the previous unit that we just did, you learned that x plus y squared is equals to x squared plus 2xy plus y squared. Therefore, in a trinomial, we will factorize into, or a trinomial will factorize into a perfect square if the first and the last term are perfect squares. For example, if x and x, or if x by x is equals to x squared, the middle term is equals to 2 times the first term and the last term. For example, x squared plus 25 plus 10x plus 25 is equals to x to the power of 5. X plus 5 multiplied by a bracket of x plus 5, which will be x plus 5 to the power of 2. But to just demonstrate something here, before we move forward, I just want to show you something, or to rectify what I was telling you. When we're dealing with the difference of two squares, there was a mistake here with the solving here. This is supposed to be x minus 5 multiplied by bracket of x plus 5 to get x minus 5 squared. To prove this, look at this example in perfect squares. The next thing that we're going to look at on the ways to factorize is trinomials of the form x squared plus bx plus c. When factorizing a trinomial, if the third term of a trinomial is positive, we use the sum of the factors of the third term to give us the middle term. If the third term of a trinomial is negative, we use the difference between the factors of the third term to give us the middle term. We use the following rules to determine or to decide on the signs of the binomials. If the third term of a trinomial is positive, then the signs between the terms in the binomial are the same, both positive or negative. If the third term of the trinomial is negative, then the signs between the terms of the binomials are different. This is an example. If you have x squared plus 3x plus 2, this will be factorized as open bracket or the bracket of x plus 2 multiplied by the bracket of x plus 1. Before we move on, let me explain this by the information that we're already given here. So if they say that if the third term of a trinomial is positive, we use the sum of the factors in the third, or the factors of the third. So this is just used to give that middle term, which is this one. If the third term, that is if we're multiplying these brackets to get back to this, if the third term of the trinomial is negative, we use the difference between the factors of the third and give us the middle term. Use the following rules to decide the signs of the binomials. So this time I want to show you the signs specifically, because this is where most people make common mistakes. If the third term of a trinomial is positive, then the signs between the term in the binomials are the same, positive or negative. I'll repeat this. If the third term in the trinomial is positive, just like this is term 1, term 2, and term 3, which is positive 2. So therefore, in my brackets, it means that my signs are going to be the same. It's either they're going to be both negative or positive. And if the third term of the trinomial is negative, then the signs between the terms of the binomials are different. If this was a minus, then you will get a plus or minus here, or a minus. And if it's positive, it's either going to be both negative or it's going to be both positive. Just like we see here, because the third term is plus 2, then the brackets are both positive. The next thing that we're going to look at is trinomials of the form ax squared plus bx plus c. So the difference between the trinomials in that previous form and this one is that now this one has the coefficient a, meaning it could be any number. In this case, the rules are the same as in the previous section, except that now we need to consider the factors of the coefficient of x squared and the last term. For example, if you have 6x squared plus x minus 15, this is a bit different from this because this one is just basic and as simple as, grade 8. X squared plus 3x plus 2 in this side, but on this side we have 6x squared plus x minus 15. So what we're going to do is we're going to multiply the coefficient of the squared term, which is 6, by the last term, which is 15, negative 15. And the answer to that will be negative 19. The next thing that we're going to do is we're going to look for factors of 90, negative 90, that will give a positive 1, which is the middle term. The coefficient of the middle term, which is just what I said, when added. So when added, minus 9 multiplied by 10 is equals to negative 90. And negative 90 plus 10 gives you 1. So therefore now you have your factors. Then now the next thing that you're going to do is you're going to rewrite 6x squared plus x minus 15. And then you're going to rewrite it as 6x squared plus 10x minus 9x minus 15. Why do you do that? It's basic. This is a way of simplifying this expression. Remember that now you're going to write the factors of these two, that when you multiply these two, when you multiply 10 and 9, you will get the negative 90. And when you subtract 10 and 9, you are going to get the value of 1, which is what you have as your middle term. So when you write it like that, you write it in this manner, in such a way that it's going to be easy for you to see things. So you're going to group the terms now in a way that suits you best, or in the way that suits the expression best. The group terms, or grouping the terms, you are going to group it as 6x squared plus 10x minus 9x plus 15. When you group it like this, the aim is to come up with come up with 3 brackets whereby 2 of the brackets, okay, let me simplify this. The main of this, or the main objective of this, with these 2 brackets, the aim that we're trying to reach here, or the objective that we're trying to reach, is that we have to take out a common factor in both of them, whereby the brackets that remain will be the same with each other, because there's a law in mathematics which we are going to apply to this. So let's take out the common factor from each set of the bracket. Before we do that, think about the common factor between 6x squared and 10x. And at the same time, think about a common factor between 9x and 15. What common factors, or what do those 2 brackets have in common? What do those 2 numbers in each bracket have in common? Those are the kind of questions that you should be asking yourself. Remember when you did common factors in the beginning of this lesson, you apply the very same knowledge. For example, here you can have, let's start with the numbers. 2 numbers that can go into both 6 and 10. Can 6 go into 6? Yes. Can 6 go into 10? No, it can't. What about the factors of 6 which can go both into 6 and 10? Think about 3. Can 3 go into 10? No. So that automatically cancels it out. So the factor that you have here is 2 and 2. 2 goes into 6 3 times, and 2 goes into 10 5 times. And another common factor that we have is they have the same base of x. So you automatically have, or you already have, a common factor of 2x for the first bracket. And in the second bracket, which is the 9x plus 15, what you have there, look at the numbers. What do those numbers have in common? It's 9, it's 15. Can 9 go into 15? No, it can't. What are the other factors of 9 which can go both into 9 and 15? 3. Can 3 go into 9? 3, 6, 9. Yes, it can. 3 times. Can 3 go into 15? 3, 6, 9, 12, 15. Yes, it goes in 5 times. So the common factor that you're going to remove from here is 3. There's a base of x, there's no base of x, so therefore the common factor between these two is just 3. To demonstrate, this is what I was saying. 2x, open bracket, 3x plus 5. If you want to take this back, please prove this on your own. You're going to say 2x multiplied by 3x, which is going to be 6x squared. And then 2x multiplied by 5, which is going to be 10x, which is what you have in that bracket. Then you're going to subtract it. 3 multiplied by 3x is going to be 9x, which is what you have there. Negative 3 multiplied by 5, you are going to get a 15, which is going to be negative later on. So with this, there's a special law which I love so much. Look at what you have here. You have this multiplied by a certain bracket and this multiplied by a certain bracket, but these brackets are the same. 3x plus 5, 3x plus 5. So those are the things that are common in that kind of an expression. So what you're going to do is you're just going to write only one bracket of 3x plus 5, and you're going to be left with 2x minus 3 as the other bracket. So this will be how you factorize that kind of a trinomial. Therefore, 6x squared plus x minus 15 is equals to 6x squared plus 10x minus 9x minus 15, which is therefore 2x open bracket 3x plus 5 minus 3 open bracket 3x plus 5, which is then simplified into that. Then that is how you factorize it. Please prove this on your own to see if you understand. When you prove this, you should be able to go back to the original expression. Moving on. There's another way to do this, to factorize. You factorize by grouping. This is one of the common ways of factorizing, especially from grade 8 and grade 9, which you have already learned. We're still going to continue with the same procedure. If an expression has got 4 or more terms, but has no factor common to all of them, then we can often group the terms, factorize each group, and then remove a common factor. I'll repeat this. If an expression has got 4 or more terms, but has no factor to all of them, then we can often group the terms, factorize each group, and then remove a common factor. What do I mean by this? This is where it gets very interesting and very difficult for many students. Imagine having an expression x to the power of 3 minus 3x to the power of 2 plus 2x minus 6. This is a very complex expression when it comes to factorizing, but you can factorize it by grouping. You cannot factorize it the way we're doing here, nor here. Why? Because now you have you no longer have a trinomial, but you have a fournomial, if that's even a thing, or a quadnomial. Yeah, that actually makes much more better sense. Quadnomial. So the next thing that you're going to do is you're going to say x to the power of 3 minus 3 to the power of x squared plus 2x minus 6. This is just called grouping. You're going to group this and this and this and this. It's going to look something like what we have in the trinomial in the form of ax squared plus bx plus c. It's simple. You just put bracket there and bracket there. So you group the terms together by using brackets. The next thing that you're going to do is you're going to take out a common factor. If you have x cubed minus 3x squared, look at what we already learned. What we already learned is that we know that whenever you have this, you can take out a common factor. You look for a common factor. The common factor that you have here, what is it? You're going to have 1 and 3. Obviously, if it's 1 and 3, there's not much you can do there. So look at the bases. They have the same base of x with different exponents. So you just take the lowest exponent because it can also go into this. So that will be your common factor, which is x squared. And then you look at the next bracket where you have 2x minus 6. They do not have the same base, but they have the same coefficient. There's 2 and then there's 6. Think about it. Can 2 go into 2? Yes. Can 2 go into 6? Yes. So therefore, the common factor into this will be 2. And here's just something very interesting and fun. You have 2 to the power of x, sorry about this, 2 to the power of x, x to the power of 2, open bracket, x minus 3, plus 2 to the power, 2 multiplied by a bracket of x minus 3. What you notice about this is the same thing that we had here, whereby we had two brackets which were common, and then these two multiplying. So you're going to apply the same law, and then you're going to have it as these brackets which is similar, which is x minus 3 multiplied by a bracket of x squared plus 2. That's how you factorize by grouping. This is very complex for many students, but it's very simple. Remember, if you're given something like this, whereby it's a quadnomial, I don't know what that is, I just made that word up, but I hope you understand. I'm just thinking of a quad, or that quad bike, whereby it has 4 wheels. So this one has got 4 terms to it: 1, 2, 3, and 4. So all you do is you just put the brackets there, which is called grouping. You take out a common factor in each bracket, and then you are going to find that when you have that, you're gonna be left with a two brackets which are the same. So you just write one of those brackets, say x squared plus 2, which will be your solution. Moving on to something else. That was cool, hey? Factorizing the sum of different cubes. This is another way of factorizing, but then now factorizing something a little bit more complex. The difference between two cubes factorizes as, imagine having a cube of a to the power of 3 minus b to the power of 3. Remember, we already have factorized the sum of two squares. Now we're factorizing the sum of two cubes. This is how you do it. How you do it is you're going to take out a common factor of a minus b. And how you're going to be left with this, or what you're going to be left with, you're going to be left with a squared plus ab plus b squared. Think about this. A cubed is more like, whenever you hear something called a cube, whenever you see something called a squared, whenever you see an exponent, at the back of your head, always think of a square root. Because a square root on its own, a normal square root, let's just say a square root of x, you can write it as, you can simply write it as, a square root of x, you can write it as x to the power of a half. Okay, x to the power of 1 over 2. So it's a base with a fractional exponent. So whenever you have a to the power of 3, and then whenever you're working with this kind of things, with the cubes, think of a square root at the back of your head. So the first factor is, you open a bracket, a cube root of the first term, which is a, minus a cube root of the second term. That is the first factor, which is what you have somewhere there. The second factor, which is this trinomial here, a squared plus ab plus b squared. So the second factor is the square of the first term, okay, the opposite sign, and then the product of the two terms, which is just going to be the multiplication of a and b, and plus, this is the sign, the square of the last term. If you can just write this down, this little sentence down, and memorize that, and always use that as a guide, then this will not be a problem or a challenge for you. I'll repeat this. If you're having a to the power of 3 minus b to the power of 3, what you do is, how you will get the first term of a minus b is just simply this minus this, and then the second term being this trinomial, you're going to say the square of the first term, which is a squared, okay, and then the sign that you are going to write there is the opposite sign of what you have. You have a negative here, so therefore you're going to say a positive this side. And then you're gonna have the product of the two terms. By the product of the two terms in mathematics, they just mean that is the multiplication of the first term and the second term. So it's more like the sum of them. But when they say sum, they're talking about addition. But when they say a product, they're talking about multiplication. So you're going to have the multiplication of the first term and the second term, which in this case is a and b, whereby the answer will be a times b, which is ab. And then it's going to be a plus, and then you're going to say the square of the last term. Let's just look at an example. Y to the power of 3 minus 64. For example, think of a cube. This 64 is actually a cube for something. 4 to the power of 4 to the power of 3, or 4 cubed, is equals to 64. Please do confirm that. And then the next thing that we're going to do is, this is the same thing as having y to the power of 3, or y cubed, minus 4 cubed. It's just the same thing as this procedure. So what you're going to do is, you're going to take out the first term, the cube root of the first term, which is going to be basically which is just basically going to be, okay, allow me to just write this down for you. Pardon me for that. I want to make this as simple as possible for you. So let's just open our Paint. Just give me a second. My PC is quite slow. It's quite slow today. There we go. As we wait for it to just open, I would like to show you what they are talking about there. And pardon me for the handwriting. It's just that I'm using a mouse. I don't have the E-pen. So we have that right here. Let's just use a pen. Okay, this is a bit way too big. Let me just use that. Think of this as, remember that we have y cubed. Pardon my handwriting. I'm using minus 64. Remember, with this 64, let me just circle this. With this 64, let me just put it as a different color there. Okay, no. Let me just get this. With this 64 is just going to be the same thing as, let me just text this. It is just going to be the same thing as 4 to the power of 3. This is technically the same thing. I hope that you understand. Let me just maybe increase the size to this. Sorry, my PC is kind of slow today. Okay, it's not responding now, but please do pardon me a little bit. Okay, pardon me for that, it's very slow. Let me just use 24 there. Okay, it may take a little while for me to increase the size so that you can see properly. Maybe let me just use 48, or yeah, perfect. So 64 is just the same thing as 4 to the power of 3. So in other words, we have, let's just go back here. Okay, let me use my black. You have y to the power of 3 minus 4 to the power of 3. This is the cube that you are going to solve. Remember what we've just learned. The product of this is going to be, you're just going to open a bracket, y minus 4, close, open bracket. Remember, it says what? A squared of the first term, which is going to be y squared, and then the opposite sign, which is positive. And then what you're going to do from here is going to be the product of the two, which is going to be 4 multiplied by y, which is 4y. And then this is going to be minus the squared of the second term, squared, just like that. This is how you are going to come about with that. This is how to find the factors. Let's go back to our slides. Let's go back to our slides very quickly, and then let's just work with what we have already. Perfect. So from here, with the example that we just have, in that painting, or that paint that I just gave you guys, let me just go back there. Don't be alarmed, because obviously 4 squared is equals to 16. Don't believe me? Please do confirm. So in other words, you can write this as 16, but then I think it's much better for you to actually take it step by step and write it as 4 to the power of 2, and then from there you just simplify it further and say y squared plus 4y minus 16. Okay, pardon that, 16, and then close bracket. Okay, I made a mistake from I said start from the beginning. Let's start from the current slide, because that's where we are. So this is the answer I end up having, which is what we have there. Another one is the sum of two cubes. Remember, when you say sum, we're talking about addition. When you talk about difference, it means subtraction. This is the mathematical language. So the sum of two cubes. The sum of two cubes is still the same procedure, but then now it's a little bit different with just the sign here. But other than that, the answer that you're gonna get is still derived from directly the points that we just learned here. You're still gonna, your first vector is still going to be the first term, or the cube root of the first term, minus the second term, the cube root of the second term, and it's still going to be the squared of the first term, the summation, or the product of the two terms, which is a and b in that case, but then in this case it's going to be y and 4, and then the product of the second term, which in this case is 4, so it's going to be 4 squared, which is 16. The signs, however, because it's plus, remember the second term of the second product, the sign is always the different one, or it's always inverse to the first one. So therefore, because it's plus, then the second term is going to be minus. Then this one is obviously going to be plus. I hope you understand. So it's time for some activity. Let's just work with some activity. So let me just give you a little activity in order for you to work on. So the question is, are you ready? Well, man, I'm just kidding. It's been a long lesson. So I just recommend that just close your book, and this is just the end of the lesson. So I just suggest that maybe you just go to sleep because it's been tiring. I'm also tired, and it's been a long lesson. So, well, I can just good night. Lol. I'm just checking if you're still awake. So, my question is, Uyapi, why are you closing your book? Why? So, how can you go without a lesson? So now that you're awake, let us continue. So it's time for some activity. Let's just do some quick revision based on what we already learned in this activity. Please pause this video and work on this. The first sum is the bracket of x plus 4 multiplied by the bracket of x minus 5. The second one is y minus 3 multiplied by a bracket of y minus 6. The third is the bracket of x plus 3 multiplied by the bracket of x minus 3. The reason why I'm giving you this is so that you can make sure that you know how to multiply this fully when we're talking about multiplication in terms of the different signs and how they look like and things like that. So please pause this video right now and work on this. So I assume that you had paused the video when I told you so. So now let's just work on the solution. So if you have x plus 4 multiplied by x minus 5, then the answer that you're going to have to get, you're going to multiply this bracket with this. This x with this x, which you're going to get x squared. You're going to multiply this x multiplied by negative 5, which is going to be negative 5x. You're going to multiply a positive 4 multiplied by an x is going to be a positive 4x. And then you're going to multiply a 4 with a negative 5, which you're going to get a negative 20. And the answer that you should be having should be x squared minus x minus 20. If you are not correct, please be true to yourself and do the corrections. The same procedure with this, except now we're using y's. Y multiplied by y will give you y squared, and then this y multiplied by this will give you a negative 6y. Negative 3 multiplied by y will give you a negative 3y. Negative 3 multiplied by negative 6. Remember, multiplying negative with a negative, you will get a positive. And then 3 multiplied by 6 is 18. And then from there, this and this is like terms, so you're going to add or subtract them accordingly. Negative 6 minus negative 3 will give you a negative 9. So this should be your final answer. If you are wrong, please be true to yourself, do some justice to yourself, and do corrections. Same procedure with this. X multiplied by x is going to give you x squared. X multiplied by negative 3 is going to give you negative 3x. X multiplied by x is going to give you a positive 3x. And then at 3 multiplied by 3 is going to give you a negative 9. This and this is like terms, so you're going to add, multiply, or subtract them accordingly. Negative 3 plus 3 is equals to 0, so your answer should be x squared minus 9. In which, let's just go back to that. in which you can say x squared minus 3 squared if you want to simplify it further, because 3 squared is 3 times 3, which is 369. So you can still continue and say that. So here's just some homework for you. Imagine now you're having 10x to the power of 2 minus 5x plus 5 divided by x. Well, what's a homework without a little bit of example? What you're going to do in this case, you're going to work the exact same way that you have been learning in grade 8 and grade 9, and also with what you did in the beginning of this lesson. Did you know that when you have this, it's just the same thing as 10x squared divided by an x minus 5x divided by an x plus 5 divided by x. The reason why, if you remember your grade 4 work, when you're working with fraction and when you're doing the LCDs, this x will affect or will divide, or this single x represents that it's a division of everything that is above it. So you can choose to separate it to work with it differently. So what you're going to do from there, remember the laws of exponent. So if you have 10x to the power of 2 divide by x, therefore you will subtract the exponents. Therefore you should be sitting with 10 to the power of 2 minus 1, which you're going to get 10x as a product, minus 5x divided by x, you are going to get 5x to the power of 1 minus 1, which is 0. X to the power of 0 is 1. 5 times 1 is 5, which is what you have there. 5 divided by x, there's nothing you can do there, so you leave it as a fraction. So here's just a little bit something for you to work on, and I expect this the next time we learn. The first sum that you're going to do is 4x to the power of 3 plus 2x to the power of 2 minus 2x minus 1. The second one that you're going to do is 24x to the power of 3 minus 6x squared plus 8x minus 2. Well, the solution to this, I'm going to give you the solution to that the next time we meet again. But just for the sake of simplicity, please, for the sake of justice, do yourself some justice. Do not cheat, because if you're cheating, you will only be cheating yourself. So the solution to this, I assume that you have done the homework now, or you have done this as more like a classwork. But anyway, it's homework, so therefore you are at home, so you might as well just do it now. So something for you to work on, just pause this video, work on this, and then let's work on the solutions. The solution to this, the moment you see this, it's a quadnomial, like we just gave it a name. So how you're going to work with this is you're going to work with it via grouping. You are going to put brackets there and put brackets there. And then you are going to get common factors from the bracket of 4x cubed plus 2x cubed, and then the common factor in the bracket 2x minus 1. The moment you see 4x cubed and 2x cubed, you'll realize something. 2 goes into itself, 2 goes into 2, so already that's a common factor of 2. They have the same common factor of m in the base of x. This is 3, this is 2. X squared can go into x, so therefore the common factor to this is x squared, 2x squared. And then taking out the common factor, you will find out that this will be your solution. In this 2x minus 1, the only common factor that these two have is a negative 1. There's a negative 2, there's a negative 1. That is the only common factor they have. So then now, if you're going to be left with this, you're going to be left with x squared, 2x squared, open bracket 2x plus 1. And then if you take out a common factor of negative 1, you're going to be left with a bracket which is similar to the previous. So therefore, with the laws that we've just learned, 2x squared minus 1 multiplied by a bracket of 2x plus 1. That should be your answer. With this one, it's still a quadnomial, so you are still going to group this. You are still going to just put the brackets there, and then you're going to work with that. But before you do that, I need you to realize something. Okay, let me just remove that. I need you to realize something. Before you even work with everything in this manner, always try to factorize in its simplest form. Never try to factorize anything that is not in its simplest form. If you can see this, 24, 6, 8, and 2, they have a common factor of 2. So you must take out a common factor of 2 first, and then multiply everything, which is what they did right here. So when you take out a common factor, you are going to be left with 12x cubed minus 3x cubed plus 4x minus 1. From there, you are going to group this by simply putting a bracket there and bracket there. If this is a bit too complex for you, it's fine. I will work on it with you. Let me just exit the slide and then go to my paint, open a new one, and let me show you how they did it. Let me just work with what is in the bracket. 12x to the power of 3. Let me check it. 12x to the power of 3 minus 3x squared what is this? 4x minus 1 plus 4x minus 1. Okay, plus 4x minus 1. So I'm going to use a different color for this. So you're just going to group this like that. If you have 12, you have 3. Can 3 go into itself? Yes. Can 3 go into 12? Yes. So already you have a common factor of 3. Can x squared go into itself? Yes. X squared go into x cubed? Yes, it can. So you have a common factor of 3x cubed. If you do that, what is it that I can multiply with 3x squared to give me 12x cubed? First off, to answer this, how many times does 3 go into 12? 3, 6, 9, 12. So it's obviously 4. Let me just reduce that. Let me just increase this. So it's going to be 4x. If you multiply this, you are going to get this as your answer. The next thing that you're going to do is, since you took out a common factor here, this is simply going to be minus 3x squared. What is it that I can multiply to get? That is obviously 1. Okay. Plus, let me just use a different color so that you may see. I will use green for this. This plus, and then here, the common factor here is obviously 1, so you don't have to do much there because there's nothing you can do. 4x 4x, okay, pardon me for that, 4x minus 1, close bracket. If you can see that this bracket and this bracket are the same, 4x minus 1. So you apply that special law that I just taught you, and you are going to be left with, sorry about that, you are going to be left with, let me use black, back to the brush. You're going to be left with 3x squared. You might be asking, where did I get this one? I simply got it here. And then you are going to say the other bracket, which is 4x minus 1. So this should be my answer. And you can just choose to be a genius there and be creative and say very easily done. See? Or you can say easy as pie. It's up to you what you want to do there. But my favorite is just QED, which is quite easily done. Okay, so I hope you understand from here. To go back to the slide to just confirm if we are right, that should be let me just get in here from the current slide. Let's just work here on it, which is what they did there. They took out a common factor of 3x squared there, and then they took out a common factor of 1 there. So they should be having this perfect, which is what we have there. But remember that we also have the 2, so do not forget the 2 which is outside, because what I did was I just work with what was inside the bracket. So that is how you do algebra. So this concludes this unit, or unit 3 of your algebra. And I really hope that you did learn. If you do not understand, please do not hesitate to text me or inbox me or whatever it is that you're going to do, and I'll be glad to explain. Thank you and have a good night.